Now we're going to do something a little bit different from what we've been doing in the last few problems. We're still going to work with equations of graphs and graphs, but up to now we've been taking a formula or an equation for a function, and we've been trying to draw the graph that goes with that. Now we're going to reverse things. We're going to start with a graph and try to come up with an equation that describes that graph. So here's number one. We have a graph that should look an awful lot like a sine wave to you. So in these we got to decide whether to use sine or cosine. This certainly looks like the shape of a sine graph. So I'm going to say looks like sine. And now we want to try to identify those constants a, b, c, d if they're involved in the equation for the graph. So here it's not too hard to see the 5 and negative 5, that the amplitude is 5. We can set our a constant equal to 5 here. We can also identify the period of this graph. The period, looking at the way the x-axis is marked, goes from one period, one cycle goes from 0 to 4 pi. And what we can do is we can work backwards through our formula for period to come up with a value for b. So we're going to take this period equals 2 pi over b formula that we've been using, and instead of plugging in for b, we're going to plug in for the period. We're going to put down a value for that, equals 2 pi over b. So 4 pi equals 2 pi over b. Now we can solve for b. I'm going to multiply both sides by b. 4 pi b equals 2 pi. Divide both sides by 4 pi, so b is 2 pi over 4 pi, and that's going to reduce to the fraction 1/2. So we have a value for a, we have a value for b. Now c and d have to do with phase shift, vertical shift. There's no phase shift or vertical shift needed to get this graph. So all we have to do is plug a and b into the formula for a sine function. Y is equal to 5 sine 1/2 times x. And there we got an equation for the graph in number one. Let's go ahead and do number two. Now this graph starts up on the y-axis and comes down, crosses the x and plunges to negative y and then back up. This looks more like a cosine graph to me. Now you can use sine or cosine for any one of these. Like you could always use sine or always use cosine. There's always a way to do it. But we want to avoid phase shift if we can, because phase shift is always more complicated. So here, if I really wanted to use sine for this number two, I'd have to incorporate a phase shift. If I use cosine, because we start at a max point here on the y-axis, I don't have to use phase shift, so that's definitely worth it, right? Let's see, amplitude is 0.3, I think, here, so my a value is 0.3. And period is looking, so we start here, we go all the way to we're at a high point again with cosine, that's pi over 10. So now we can solve for b like we did in the previous one. We're going to say use our period is 2 pi over b formula, but I'm replacing period with pi over 10. It's 2 pi over b. And we want to solve this little equation for b. You know, you can cross multiply if you want here. Since we have one fraction equals another, we could say pi b equals 10 times 2 pi, which is 20 pi. Divide both sides by pi, then b is 20 pi over pi, or b is 20. And so I got a b value for this second graph. And let's see, I don't see phase shift, don't see vertical shift. I think we're all set for a cosine. Y equals 0.3 cosine of 20x. Okay, so we got our second graph equation. Separate that off. And now let's look at number 3. Now, this one is a little bit trickier to deal with. One thing I notice, it's not centered on the x-axis. I see that the midline cuts through here. And the midline looks like it's y equals 2. That tells me there's a vertical shift. And that's our d constant, right? D equals 2. We're going up 2. And now, do I use sine or cosine? If I wanted to use cosine, I have to move over to 4 or over to 12. I'd have to have a phase shift. So I'm going to use sine. So I choose sine. But because we start at the midline and go down and then up, what's the amplitude here, by the way? Let's do the amplitude first. The amplitude is not 6. The amplitude is the distance from the midline to the top, or from the midline to the bottom would be the same. So it's actually 6 minus 2, which is equal to 4 units. And so the amplitude is 4. So we had to work a little bit to figure out the amplitude for this one. Because I want to start my cycle or period by going down first, I have to choose a value that's negative. So I'm actually taking a reflection of the sine wave through the horizontal axis. So I got a D, I got an A, that's my period. Period goes from x equals 0 out to x equals 16. Okay, so here we go again using that formula for b backwards, right? Period is 2 pi over b. We're going to plug in 16 equals 2 pi over b and solve for b. 16b is 2 pi, so b is 2 pi over 16. My b value is going to be pi over 8. I reduce that. So I got a and a B and a D. I would only have a C value if we had a phase shift in number 3. I don't see a phase shift. So I think we're ready to write down our formula. So we're using sine, but we have to write y equals negative 4 sine of bx, so it's going to be pi over 8x, close parentheses, plus 2 on the outside to represent our vertical shift for that graph. So we got number 1, number 2, and number 3, and I'm kind of running out of room here. So I think I'm going to do number 4 in a separate video.